All right, so the next shape we're looking at is our rectangle. Remember, we have Chad the rectangle. First of all, our definition of a rectangle, four-sided shape with all right angles here. And we also know that a rectangle has all parallelogram properties. So everything we said about the parallelogram is also going to be true. Opposite parallel sides, opposite congruent sides. The diagonals are going to bisect each other. Okay, but in addition to the diagonals bisecting each other, they're also congruent. So this piece here, they're congruent, but they're also congruent to the other piece. So we know in total, CA, that is congruent to HD in this diagram here. Okay. So first of all, looking at finding missing angles. So I'm going to do a different angle from what's on your practice test, so you can kind of try it with a different number on your own. Let's just pretend that this is an 18-degree angle, okay? And then you would therefore need to find the measure of every other angle in the diagram. Well, first thing we know is that we have congruent sides here. And what that creates is it creates congruent isosceles triangles. So this triangle here is an isosceles triangle. And so that means we have two congruent base angles. I'm going to put in 18 degrees here. Okay, now because this triangle here, it is actually congruent to the triangle opposite to it here, I would be able to say that also this is 18 degrees. And I would be able to say that this is 18 degrees. Okay. Now we've found for some of the angles in the diagram. We'll find the rest. The next one we can maybe go to is angle 1 here. I know that in total, the angle at this corner is going to be 90 degrees, 90 in total. So I would take 90 and I would go ahead and subtract 18. And that's going to give me the measure for angle 1, and then we can place that into the diagram. Okay, so this is going to be 72 degrees. So that's going to be the measure for angle 1, 72. That'll go here, 72. That'll go here, 72, and here, 72 as well. Okay, two sets of congruent isosceles triangles. And now for the last two angles, this angle here, well, we have a triangle, and in that triangle, we have 180 degrees. Remember, triangle sum theorem, we always have 180 in total. So I would just take 180 and I would subtract the 18 and subtract the 18. Let's see what we have left from that. So 180 minus 18 minus 18 is going to be 144. And that should be your angle here. And then we have an angle that's vertical to it. That would be angle 3. So that would also be 144. And then your last angle, there's two ways that you can kind of go about solving for this last angle, angle 2. Let me do green, a different color here. So we could do 180 minus 72 minus 72 because we have a triangle. We could also try 180 minus 144 because we have essentially a straight angle between those two as well. So 180 minus 144, or 2 of the 72s, that would give us 36 degrees here. And then vertical to it, that would be 36. So no matter what type of rectangle you have, if you are given one angle measure in that rectangle, you can solve for all of the rest of the angle measures based on that. Okay. Next question on a rectangle, number 7. Well, we know these angles here are complementary. They create a right angle. This is a 90-degree angle in total. We don't necessarily know that these angles at the corner are equal. Look here, they definitely were not. One was 18 degrees, one was 72. So we are not setting those equal. We don't know if they are. But what we do know is that they have a sum of 90. So I would add them together, equal it to that 90 degrees.